All right. Thanks, Javi, and thanks for that introduction. And thank you for the Open Source 101 folks and All Things Open for having me here to speak today. As Javi mentioned, I'm here to talk about functional web apps, the revenge of dynamic web apps. Um, I have to ask, are dynamic web apps actually on a rage-filled cross-country revenge tour? No, of course not. That would anthropomorphize a concept that's not really happening. But what I am seeing is a lot of backlash against static site generated things where they don't offer dynamic functionality. But regardless, I'm getting ahead of myself. I actually have to have there we go. So, who am I? I'm Simon Macdonald. I'm the head of developer experience at Begin. Begin is a startup where we're trying to make developing web applications a lot simpler. I don't know if you've ever logged into the AWS console and seen the approximately 140 different services that you get to choose from. That can get a bit overwhelming. So, what we're trying to do at Begin is to make that a lot simpler by giving you some sane defaults. Feel free to reach out to me after the conference at McDonald's. That's my handle at Twitter. It's my handle pretty much everywhere, so it's pretty easy to find me on the internet. And if you're wondering where it comes from, it's McDonald Simon Thomas. It was just available everywhere, so that's why it's such a dumb handle. What are you going to do? All right, let's get into what a dynamic web app actually is. So I have been doing web development for a really long time, so long that we used to build dynamic web apps with a thing called CGI bin. So some folks may remember in the 90s, you would use Perl scripts in order to develop dynamic web apps. But even before that, we used to write C programs to generate HTML on the fly. So let that sink in for a second. Anyway, dynamic web apps are, quite simply, they're not static. The HTML is rendered on demand. So as you request the endpoint, the HTML is created at that point in time. And it's completely required anytime you're building an API. So not only do we dynamically render things like HTML, but we may return JSON, or again, if you're really old like me, you'll remember when we generated XML as a response. The bad old days is what I like to call them. So it's not only for HTML, but it's for API requests as well. And then, of course, most dynamic web apps are backed by a database. So what we're seeing here is like the full stack, all the way from the presentation layer right down to the database. So what does a typical architecture look like? We're breaking everything up into separate concerns. So in our three separate parts, and this is sometimes called the model view controller or MVC pattern. And another way of thinking about it is separating the presentation or UI code from the application or business logic from our database. So splitting up the code in this fashion allows us to separate, frequently changing UI layer from the less frequently changing business logic. Well, at least we hope that the business logic is a bit more stable, but sometimes it isn't. As well, it abstracts your database from your business logic, allowing you to completely switch out your database. Now, I wish I was in person giving this talk because I would ask for a show of hands how many people have actually completely swapped out their database in a production running application. I'd say that number is fairly low. And for those of you who have done it once, you would never want to do it again. But in theory, the MVC pattern allows you to do something like that. And you may have noticed that this pattern also allowed people to kind of specialize in certain parts of the stack, whether you are a front-end developer, a back-end developer, or a data engineer. All right. The traditional dynamic web ecosystem had a lot of different application frameworks that you could choose from: Rails, Django, Express, WordPress, Laravel. I always pronounce that wrong, so I tried to hit that correctly this time. And many others that we don't even list here that enabled you in order to build dynamic web applications. In fact, today I was trying to book a COVID test as I am visiting the States next week to see my parents. Very excited about that. But their web application is built on Java server faces, which is pretty interesting. I haven't seen that in quite a while, so that'll tell you the last time my doctor's website got updated. Anyway, I digress. Let's use Rails as an example, as it is literally MVC. So when it comes to the model side of things, we have the active record. The view is we have the action view. And for the controller, we have the action controller. So this is what a Rails application looks like logically. And that's basically how we would split up our code in our project to handle these different concerns. When it comes to the physical side of things, it's a lot different than what the source code looks like. So this is a typical deployment of a 3-tier architecture, albeit we've simplified it quite a bit. We've omitted some parts for clarity, but it's roughly what happens in a 3-tier architecture. Basically, we're load balancing a fleet of servers in order to share the traffic. And all of these servers are talking to a backend database or databases in order to do, data retrieval or caching of certain things that are built on the fly. Now, all of these bits can scale horizontally ad infinitum in theory as well. And when it comes to your deployment, this is where things get a little messy. Well, what we end up deployed as our logical architecture only goes into the web servers. So that's what's surrounded with that blue dash box. And then we repeat it as many times as we need it. The more traffic, the more web servers we need, the more deployments we have to do. And if anything goes wrong with any of those deployments, we have to roll back X number of servers. So that's a big problem, especially if you run into an issue with deployment about halfway through your rollout. The other big problem is that there's many parts of the architecture that aren't in source control at all. That's bad. So how do you repeat this deployment? Now, places like Heroku, which was a fantastic website back in the day, it took care of that part of the infrastructure for you as kind of infrastructure as no code. So if you wrote an application in a certain way, all of these parts were taken care of for you. But over time, that didn't scale very well. So new tools like Ansible or Puppet or Chef came around. These configuration manifest tools that would allow you to check in a manifest or a configuration file that describes the infrastructure for you. And this is what eventually evolved into infrastructure as code. It's not unlike how we check in our package.json in order to specify code dependencies. Infrastructure as code allows you to declare cloud dependencies in something like Terraform or CloudFormation. And now you don't need to worry or wonder how to reproduce exactly the environment or what gets deployed. Everything is there for you. So there are some problems with the traditional dynamic app. First off, the 3-tier logical architecture is not the same as what we physically have deployed. So if you do not use infrastructure as code, it is incredibly difficult to deploy because the infrastructure is not versioned. How do you make sure that you have exactly what you've planned on having? 2, the rollout can be slow. You have to update a server at a time, and it may take quite some time before them all to be up to speed. And servers are kind of difficult to scale horizontally. I mean, that's why we moved into serverless and containers, because we had to get away from stuff like that. Now, the other thing is when you're getting into rendering of the of the HTML, it's kind of slow to render because traditional RDBMS or databases are a little slower than the modern databases that we have now. The maintenance cost is absolutely huge. It is not fun to be patching, updating, debugging, doing all these sorts of things with all of these servers. And if you need to add any additional functionality that's not part of the MVC, like background jobs, it's a clunky bolt-on. So these bits of functionality are not automatically added into the platform. So if you're doing kind of a cron job or you have some sort of pub sub or queue mechanism, you have to add additional things that may be coming from a whole bunch of different providers. So you're stitching them together. Sorry, tea break. So that's not fun. And we have ways around things. If you're not super familiar with infrastructure as code, and I haven't convinced you that it is a good idea, then I need to make a book recommendation for you. I read way too much, and I don't give out 5 stars on books very often, but this is definitely a 5-star book. It's called Accelerate. It's by Forsgren, Humble, and Kim. If you've read or ever heard about the Phoenix Project, this is the nonfiction version of the Phoenix Project. So this is the actual data that they collected from a number of companies, and it is very eye-opening, and I recommend that everybody read it. Excuse me. So after we got through doing all of this dynamic applications and we ran into the various problems that we had with things, we had to think of a better way of doing things. And that's where the Jamstack enters. So The Jamstack, the idea is to totally build everything into a static artifact. So we pre-render everything and serve it via the CDN. Any kind of dynamic functionality happens on the client at runtime and is provided by JavaScript. So that's wonderful because the deployment is immutable and nothing is ever really changing. You get the same static files all the time if nothing has changed in the file. The problem is we tend to put a lot of code for the client side, dynamic side of things, and that all gets mashed together in like one big artifact, which can be very difficult. And when it comes to the backend, that is another thing that we can outsource to other service providers. Now, your core business competency may not be something like authentication or authorization, so you may reach out to another provider. And a typical example is using somebody like Okta or Auth0 for authentication because you don't really want to have to worry about that. Incidentally, I did send out some hug ops to my friends at Okta last week for everything that they had to deal with. If there's anybody from Okta on the call right now, I feel for you. I hope things are going better. Now, looking at the Jamstack logical architecture, it comes out pretty clean. In fact, it's not even a 3-tier architecture, it's more of a 2-tier architecture. And that's going all the way back to the original client server, where all of the business logic was pushed down to the client, and it would only talk back to the database in order to grab the freshest data. So in the case of the Jamstack, we put all of our application logic onto the client and we make our API calls back to the server. So that does tend to simplify things, although it does tend to overload the client a little bit. Now, the physical architecture looks like this. It turns to be different, but pretty close to how the logical architecture looks like. Again, we're mixing our business logic and our presentation code into one artifact, which gets deployed to the client. So that's where the static assets are. And then again, we make our network API calls back to all of these backend services. And you can see there could be many different backend services that we have to talk to in order to provide functionality for our application. So when it comes to, deployment, that's okay when we're only deploying static assets. It's just that blue box that we have there. The problem is the other parts are not in our version control, and they're not under our control at all, which is a little problematic. Any times that one of your backend providers makes a change, then you have some unplanned work that you have to go ahead and take care of. So that's a little bit of an issue. Now, I know it's going to sound like I really hate the Jamstack, and I don't want you to come away from this talk thinking that is the case. These are just trade-offs. I'm not saying that you shouldn't use the Jamstack. In fact, I have used Jamstack on a number of projects myself, but you have to consider your use case. And here are a couple of trade-offs that you may need to be aware of when you come to picking Jamstack for your project. First, we have slow builds. When you pick up Jamstack, whatever the framework that you're using for it, and you start to put together a few pages, maybe you're building a small personal blog or your own website, 5-10 pages, builds are super quick. Everything is great. The developer experience is wonderful. However, as you tend to build out to 5,000 pages in your application, that's when the build gets progressively slower. And I can tell you this from experience. One of the companies that I worked at, we were using the Jamstack in order to build all of the developer documentation inside the company. And the build got extremely slow as we got more successful and more people wanted to be added to the developer doc site. Now, there are ways that you can get around it by doing some incremental builds, but in that case, you're adding a lot of additional kind of complexity onto your build. You have to handle that yourself. Some of the Jamstack cloud providers have this functionality as well, but just be aware that the more data you put into it, the slower that your build is going to be. Also, dynamic functionality becomes a second-class citizen. You don't have access to the full stack. So there are things that you would want to do at the database that are not as easy to find. As well, it encourages things like loading spinners or progress indicators because the HTML is loaded by your browser first, and then it has to make one or more API calls in order to get this dynamic information. again, alluding back to the developer documentation site I worked on, it was wonderful. It did exactly the job that it wanted to, except after we got successful with it, people kept wanting to shoehorn more dynamic functionality into it, and that is not how it was originally designed. And it made it very difficult to add this kind of dynamic functionality. And so another issue is that because everything is on the client, it becomes more difficult to secure things. So you're doing a lot of network calls back to your backend or to a remote backend in order to do API calls. So you have to worry about the networking, the security, the privacy, all that stuff is a bit clunky. Like, how do you actually make sure that your Jamstack site is not abusing these backend services by, like, hackers could get in there. And anytime you want to add functionality via cloud functions, that's kind of like an afterthought in a lot of Jamstack. Now, I moved the mouse. The ecosystem is quite complex. There's a whole set of libraries and tools that you kind of need to glue together in order to do anything. So as you're adding functionality to the site, one of the key things is to have something like Sneak. It's really, and at this point, required, because you're pulling in third-party SDKs from all over the place in order to make those backend API calls. So unless you have something like Sneak scanning your code, making sure that there's no vulnerabilities, you could get basically bitten in the ass. One particular scenario that happened less than 2 weeks ago, the Node IPC maintainer, he decided that he was going to protest the war in Ukraine, and I'm all for protesting, but what he did was pretty bad, because anytime he detected that the Node IPC code was running on an IP address in Russia, it would delete files on the hard drive. And that's pretty scary to think that that can happen. And that may happen with any of your dependencies. So, the more dependencies you're adding to your application, the larger the attack surface becomes for hackers. And sometimes the hack is coming from inside the house, which is super scary. As well, transpiling into like a single JavaScript file or a set of JavaScript files as you're kind of concatenating all of these different third-party libraries you're using. It's complex, it's brittle. I particularly think Webpack is fantastic, but I hope to never have to use Webpack ever again in my life. It is frustrating. That is all I can say. And lots of times these third-party libraries release updates, and you are basically need to pull them in. So it's unplanned work that you may not be thinking of doing. And then there's just this weird asymmetry between what your infrastructure is and what your code is. Your infrastructure is just a bunch of static assets, and your code is very advanced. So this is the rebound effect. Now, some of you may have heard about this, and again, quick tea break. And in this case, it's often talked about where you have these new gains in technology and you think that it's going to super improve things. And we tend to overestimate how much it's actually going to improve things. And there's other parts to the improvements that we do not consider, and they end up actually either diminishing or actually making things worse than they were before. You often see this around making cars more fuel efficient. So cars became more fuel efficient. So we all assumed, oh, this is great. People are going to, save money on gas. But what actually happens is because they weren't spending as much on gas, they actually drove more and spent exactly the same amount of money on gas. So that's the unintended consequences of the rebound effect. And I would like to posit that JavaScript also has a rebound effect. Quite often we'll pull in a new JavaScript framework and we feel like, yes, this is going to solve all of my problems. It's going to make everything better. But then the perceived kind of advancement and the actual advancement is not as great. And usually what ends up happening is this new JavaScript framework, it adds so much JavaScript to the client that it diminishes the overall beneficial effects. And in some cases just makes things worse. I would like to, I'm not trying to kind of talk down to anybody who's using some JavaScript frameworks right now, but I would suggest your next project you start off, even if it's something you're just doing yourself, just try to build it all without JavaScript. Just see how much you can do with just the regular, like the form elements and everything else that's already in the browser, and then progressively enhance things as you go along, instead of immediately reaching for a JavaScript framework that's going to add megabytes of JavaScript to your client side. Anyway, I will get off my soapbox now. So what we want to talk about a bit more is functional web apps, which is a different approach to this type of thing. First, the functional web app is HTML first. So all of the dynamic personalization, it's done at the server. The HTML is pushed down to the client. So there's no loading spinner happening there. All of the personalization is already done. And because we're pushing HTML down to the client, we're already considering the accessibility of it. So anything that lands on the client before it even has to go off and load more JavaScript should be usable. We saw an example, I think a couple of months ago, where a grandma could not even book her COVID-19 vaccine because her browser didn't support the version of JavaScript that was being used for the site, which is kind of the opposite problem that I've been having. Anyway, so let's always make sure that whatever we deliver to the clients is always usable, no matter how old their browser is. Now, everything is cloud-centric. So you have the entire system is just done in pure functions. So any of the front-end code is done in functions, any of the back-end code is done in functions, and we are rendering HTML on demand. So that allows us to kind of split everything down into small single-use functions, which are incredibly quick to write and debug and can help you out a ton when you're building applications like this. And as well, it opens us up to the entire stack of capabilities. So many cloud providers have functionality like queues, events, cron jobs built into their systems, so you can just leverage that right away. On the database side of things, our databases in the cloud are on demand. They do auto scaling, so you don't have to make a socket connection to a remote database, which is one of the slowest things that you'll ever have to do in computer science. I was recently working with an older RDBMS in order to pull some data from it, and I was absolutely shocked by the amount of time it takes for a socket connection to get spun up. I know we have database connection pools and we have ways around this, but the initial connection is quite slow. With cloud databases, your latency is like single-digit millisecond. So there's no need to set up a connection pool. You are just basically waiting the briefest amount of times in order to query the data from the database. And then for deployment, the deployment is completely declarative. Usually we're using infrastructure as code for that. And so that you can use things like CloudFormation or Terraform in order to specify it. But as well as the infrastructure as code piece for the cloud, you also want to make sure you have something like a package.json and a package lock in order to specify exactly what dependencies that you have, so that anytime that you do a deploy, you know exactly what has gone out, not only from the dependency side for your code, but for all of your cloud primitives as well. So the logical architecture is quite simple. Your view and your controller are both cloud functions, and your data access layer is just the database. Again, it looks a bit like the two-tiered side of things, but you can separate it out into 3 tiers, but that's what your logical architecture looks like. Yeah, so you're putting your presentation and business logic in the cloud functions that talk to your data access layer. And you probably think this is a terrible idea until you try to use it. So I suggest try to use it. Well, one sec. Boy, you can tell I've been talking all day. Anyway, the functional web physical architecture looks a lot like this. So everything in that gray box you have control over because you specified all of that stuff using infrastructure as code. So you still have a CDN and you still have static assets. So if you have a web application that has a build step, you have a place to deploy those files, even though if you follow the full kind of functional web app architectural pattern, you don't even need this kind of thing. And all of this functionality will scale out horizontally as you need it. And it all talks to a backend database. So what's nice about this type of way of thinking of things is that you get one declarative, fully deterministic artifact. So if you ever need to roll back to a known good state, you can do so with a high degree of confidence because it's all locked in there. Um, Personally, I think that ClickOps is an anti-pattern. So anytime you have a web user interface that you go into and allows you to scale up how much memory your servers are using or how many servers you actually have, that's kind of a bad idea because you will get a kind of this drift where what you initially deployed and what's actually running in production are completely different. So you can get a mismatch between what you have checked into source control and what you have running in production. And that can cause some problems when people go to upgrade to a new version. You want to have everything declared as infrastructure as code so that you can reproduce these things. Now, if you look at Jamstack and FWA side by side, you can see that on the Jamstack, you really only have control over the static assets, while on functional web apps, you have control of everything, which is wonderful. And you're just going to get a better experience when it comes to using functional web apps. So taking a look at some of their advantages, the first thing I would say is you have access to the entire stack. That makes things incredibly powerful. So you're, as a developer, you're able to work with the front end, the back end, the database. It's all there for you. You have access to cron jobs, WebSockets, events, PubSub, everything. The second thing is it's just way more fun. You spend a lot less time maintaining code and more time shipping code. Now, I have done a lot of work in React, and I love that React said it would improve my developer experience, and it really did. And I was happier with that for a while. So it's always more fun to be out there solving problems than it is to be working on ceremony. But what I have noticed with React and some of those other tools is that they make developer experience a lot better. They don't necessarily make user experience a lot better as we continue to push JavaScript on the users, making the browsers run slower. So if you can move away from some of that, it will make the overall user experience a lot better. And you'll notice that doing things slightly differently can make your developer experience a lot better as well, because you're moving fast, you're shipping things instead of constantly keeping up with the latest version of whatever package just got updated. Anyway, and you're not dealing with any kind of breaking changes or unplanned work that are coming out of those breaking changes. And the last advantage is that it's fast. Everything is sent to the client, so it's ready to be used as soon as it hits the client. Nothing is being hidden behind spinners or multiple API calls in order to get data down. So that makes the experience for the client a lot nicer. Now, what about some of the problems? So here's some things that constantly come up, and there are ways to mitigate them. And the first thing is the cold start. So when you're using cloud functions, you want to start with small single responsibility cloud functions, and that's how you combat cold starts. So we've known for a while now that a large code footprint in your cloud function correlates with longer cold starts. So the more code that's parsed at the startup of your cloud function, the longer the cold start will be. A good rule of thumb is to keep the payload size below 5 megabytes, which keeps your cold starts under a second, and frequently under 200 milliseconds, which is barely noticeable for cold starts. If your cold start is over 1 second, then your cloud function is probably too big. But what I mean by too big is it's parsing too much code, or it's parsing some really inefficient code. You can have a payload that is 100 megabytes, but if it barely parses any of the code in order to start up, then your cold start is going to be negligible. And if all of that, if you kind of strip out some of those dependencies, or you pick a better library in order to use, and you're still having over a second cold starts because of some very intense stuff that you're doing, then you can pre-provision the capacity. The database story is still coming along. There are a lot of good databases like Dynamo, Cosmos, PlanetScale, and Fauna, which provide you absolutely great performance. Great performance no matter how much data you have. So you really won't need to think about your data layer anymore. And I personally love that because I never took databases in university, and if I never have to write another SQL statement, I will be very happy with that. Infrastructure as code can be pretty complex and kind of scary. The CloudFormation format is very verbose, and so much so that we actually wrote our own format called Arc, and that's part of the Architect open source project. It makes dealing with CloudFormation a lot easier. And the last thing is, you pretty much have to go all in with one cloud provider. Things are not very portable. So in AWS function, it's not the same as an Azure function, which is not the same as a Cloudflare function. So if your primary goal is to be portable, then you probably want to run Kubernetes instead. Personally, I think you should pick one cloud provider and go all in on it. We use Amazon and we're extremely happy with it. Obviously, AWS is not going anywhere. And one of the things they do is they never ship breaking changes. So that reduces the amount of unplanned work we have. So we talked about that earlier. Now, there is a growing ecosystem for functional web apps, obviously OpenJS Architect, which is an open source project that I work on, but you can use AWS, Azure, Cloudflare, Deno, or GCP. Begin is a way of deploying OpenJS Architect applications. If you know of any other parts of the ecosystem that can do functional web apps, please let me know because I'm always looking to add them. And it's really not just us who are doing functional web applications. We've actually seen them in the wild. The BBC website is completely built as a functional web app. So everything comes down to you over the wire. There's not a lot of API calls. Cloud Guru, Bustle, and of course, we drink our own champagne at Begin. So all of our web applications are built using the functional web app paradigm as well. So the static app, the functional web app. So we have this kind of, modern architectural pattern. So it's always HTML first, and we think about progressive enhancement all the time. So we want to be able to give the user the best experience without having to load any JavaScript. Cloud Functions centered development model. Cloud Functions are pretty amazing. One of the things I really love about them is that if you need to update one cloud function, you don't need to update your entire application. And in fact, if you decide that this cloud function would be better, you have it written in JavaScript, let's say, and you think that actually it would run a lot faster if it was in Go, you can completely re-implement that cloud function in Go and deploy it, and your users will never know the difference. And you've gained the performance benefits of writing things in a completely different language. Managed databases built in give you that incredible speed boost because you're not waiting for socket connections. And if you do kind of explicit declarative deployment using infrastructure as code, you're going to save yourself a lot of heartaches down the line. So if you want to learn more, a few resources for you. You can go to fwa.dev and read about things. You can check out the Architect open source project. And if you want to just deploy an app and then take a look at it, you can even just click this button in the presentation, which I will share that slides later. And of course, please tell me how wrong I am at Macdonald ST. Now, excuse me, we're getting a little bit late in the presentation, but I just want to show you a really quick demo here. And there's not that much to show, but I want to give you an idea of what things look like in the Architect format versus the CloudFormation format. And for some reason, yeah, my mouse is not working there. And let me go back to sharing. And I'll share my desktop. All right, so as I mentioned, the Architect format is a very terse way of setting up your CloudFormation. So we give it an app name, we tell it we need some static assets, and we say the HTTP. We have 4 different routes for getting all of our to-dos, creating a new one, deleting one, and updating one. For the database, for DynamoDB, we're going to set up a data table and then have our scope, data, and time to life things all set up. So you can see that that is roughly 19 lines of code. If you were to write that in CloudFormation, it's a little bit more verbose, shall we say. Anyway, it scrolls on to about, 729 lines of CloudFormation. So again, infrastructure as code can be a little bit daunting, but there are ways to make it a lot easier. Over here with our application, we can just create a new to-do, and I actually scrolled that off the side of the screen. And if we update it, we can complete it or we can delete it. So all of that functionality was done using Cloud Functions that we have built. You can see very simple to get all of the to-dos. We're just basically coming into our handler, asking to get all of the to-dos in from our database. Then we're just going to push them into an array and send them back down to our application. So the application itself, what requests it is from our index JavaScript, which for some reason I can't see, but anyway, not that important. Oh wait, yeah, I think for our particular example, everything is just actually located inside of the HTML. Not that important. What I'm really trying to get across is that it's very simple to get one of these applications up and running. So I just want to say thank you for having me, and I am more than open to questions at this point. So please let me know.
Thank you, Simon. Yeah, we have plenty of time for questions, folks. So lots of good material in Simon's talk and a demo that worked. All good things. So there's something in chat. No, okay. Everybody's happy with what they heard. So more time for tea or coffee or pick your poison.
Yeah, I'm glad everybody's happy with what they heard. One thing I forgot to mention when I was doing the demo, I'm running our demo. Architect has a local development environment, so you can actually build your application locally before you ever push it up to AWS. So it really helps accelerate your development time as you're not deploying to AWS for every change. So makes things a little bit nicer.
Awesome. Thank you for that. Well, then, I guess it's last call for questions. If not, we have till 1:30 for our next speaker. And thank you and have a great rest of your day, Simon. And
there is
something else. Yeah, please,
well, there was
please.
one quick question.
Oh, I'm sorry.
That I just saw in the chat, and is what are some of the static site generators that you've tried? So it was approximately 2.5 years ago, we did an investigation of static site generators. We evaluated, I think it was 40 different ones. So we went through all of them. Astro was not one of the ones that had bubbled up to us at that point in time. What we ended up going with for our large internal developer documentation website was Gatsby, but we had done prototypes in a lot of different static site generators. One of the things that appealed to us about Gatsby is that we had an already existing React library that followed our design system. So it made it a lot easier for us to build the application. Again, knowing what I know now, which is that we would have a lot of scope creep, we probably wouldn't have started as a static site generator, and we probably would have went with a dynamic web app right from the very beginning, because we got asked to do a lot of personalization. So we did a lot of shoehorning into that static app.